Well, in this session, we are going to discuss a case study. CBSE has introduced case studies in 12th mathematics recently. The format is very simple. There will be given a paragraph based on a mathematical problem, and there will be given 5 multiple choice questions. Out of those 5 multiple choice questions, we are to attempt any 4. Very simple. Well, I'll say that this is the easiest part of the question paper one can find. How to attempt it? Simple. किसी भी केस स्टडी को अगर आपको सॉल्व करना तो सबसे पहली जो बात आप ध्यान में रखेंगे वो ये कि पूरी की पूरी केस स्टडी को एक बार थॉरोली पूरा पढ़ लेना. उससे क्या फायदा होगा? इफ देयर इज एनी कंफ्यूजन that will be automatically resolved by the framing of the questions, because you will find that the framing of the questions will help you solving the questions. See, let's take this case study. Here there is given that Rajendra wants to construct a rectangular garden using a rock wall on one side of the garden and with fencing for the other 3 sides as shown in the figure. He has 100 feet of wire fencing. Well, obviously at one side the rock is given. That means this side fencing will not be done. It is very clearly written that the fencing is to be done on the 3 sides. Again, we'll read the question, full question out so that we can understand the problem properly. The first question is to construct the garden using 100 feet of fencing so that the maximum number of trees can be planted inside the garden. This gives us a hint that the plants are not to be planted, the trees are not to be planted on the perimeter. It is to be planted inside the garden. For that we need maximum area. Suppose you have a confusion whether the trees are to be planted along the fence, along the perimeter or inside the garden, then we must go for the second question. That is why I suggest you to read all the questions out so that the framing of the questions will help you to solve the case study. Well, the second is, if x denotes the length of the side of the garden perpendicular to the rock wall and y denote the length of the side parallel to rock wall. See, this is the rock wall, x is the side perpendicular to this rock wall and y is the side which is parallel to this rock wall. Then, and we know that the length of fencing is given simply in the question 100 feet. Now we are asked find the relation representing total amount of fencing. So total amount of fencing is 100. So obviously this will be the sum of the fencing, x plus y plus x. So obviously x plus y plus x will be equal to 100. That means 2x plus y is equal to 100. This will be the relation between x and y. Well, the third question is area of the garden as a function of x can be represented as. Suppose you were having some confusion here that it can use perimeter, like in class 11th we have discussed a question in which at equal distances some trees were to be planted. That is a different case study. So easily, if you read the whole case study, you will easily find out what you are to do. Obviously, to plant maximum number of plants inside the garden, we have to maximize the area. And just now we have found the relation between x and y, that is nothing but 2x plus y is equal to 100. 2x plus y, 2x plus y. This is not 2x plus y, this is not 2x plus y, this is 2x plus y. So carefully, 2x plus y, not 2x plus y is equal to 100. Okay. Now area. We know that area is equal to length into breadth. The length is x and breadth is y. And we are to express it as a function of x. So I can find the value of y from this part. So y here, we will get y is equal to 100 minus 2x, because y plus 2x is equal to 100. So it will give me y is equal to 100 minus 2x. Okay, so this gives me x multiplied by 100 minus 2x. That is nothing but 100x minus 2x square. So 100x minus 2x square, that is not the first one, not the second one. Yes, third one, the C part is the answer. Now the maximum value of Ax. Now we have represented area as in terms of a single variable, and we are to maximize the area. To maximize the area, the first derivative dA by dx must be 0. So we find dA by dx. On differentiating, what we get? 100 into 1 minus the derivative of x square is 2x. 2 2s are 4x. So this is dA by dx for maximum area. For critical values or for stationary points, dA by dx must be 0. dA by dx is equal to 0. That means 100 minus 4 times of x is equal to 0. That gives us x is equal to 25. So maximum value of Ax occurs at x equals to when x is equal to 25 feet. Alright. The question is very simple. When the value of x is 25 feet, then the value of the area will be maximum. What will be the maximum area? So area, we have area is equal to length into breadth. That is simply x into 100 minus 2x, because y is equal to 100 minus 2x. Let's put x is equal to 25 for maximum volume. For maximum area, x is 25. So 100 minus 2 into 25 is 50. So this will give me 25 into 50. That is nothing but 1250. So 1250 square feet. See, the very first hint to solve the question is read the question carefully. This is the length of fencing. The rock wall on one side is to be used, and the fencing is for other 3 sides only. So do not just when it is asked that the fencing, the relationship between the length of fencing and x and y is, you cannot include this y, because this is the rock wall which is to be used to construct this. Fencing is to be done on these 3 sides only. I hope the question is very clear. To attempt any case study, what we need to do is we must read the case study thoroughly. Then we will answer the asked question one by one. Well, in the next session, we'll be taking some more case studies. Thank you so much.